In modern direct drive generators, there's no gearbox. This eliminates 50% of the components of a wind turbine and has a direct positive impact on the reliability of the system. We have developed ways to make the direct drive generator even more efficient, reliable, and cost-effective. We have also made improvements to the choice and the use of better materials for many of the components, including the magnets and the laminations. This helps reduce the cost of manufacturing the generator systems by 20%. A third benefit is the reduction in the amount of vibration throughout the system, which means there's less wear and tear on important parts of the equipment, this extending their lifespan. The many improvements we have made to the design of the generator have meant that each turbine can produce more power than was previously possible. So, now we can produce the same amount of energy as before from fewer turbines or produce more power from the same number of turbines.
All the direct drive generators currently being manufactured by Siemens Gamesa Renewable Energy have been designed using improved technologies, techniques and design processes that have resulted from our collaboration with the university. The improvements and insights that have been made to the generator will stand us in good stead and allow us to meet the demand for future generations of wind.
Researchers in the Dynamics Research Group in the Department of Mechanical Engineering have created exciting and innovative ways to monitor the health of many components of the wind turbine, to provide predictions of issues and damages that need to be addressed. This is important because when turbines aren't working, the electricity they would normally produce may have to come from more expensive and less sustainable sources. Advanced notice of possible failures and damages can drastically reduce the amount of time a turbine is out of action. The maintenance and repair of components on offshore wind farms is also a very expensive task. The new technologies that we have developed use a combination of data and physics to allow us to monitor the performance of a whole wind farm, as well as individual components on each wind turbine, such as the blades or the mechanics.
Continual improvement in the methods we use to monitor the health of wind turbines and their components, and the development of the ways in which we react more effectively to health monitoring data is of critical importance to Ørsted. As a result of the massive scale of offshore wind turbines and farms and the remote, harsh conditions in which they operate, rectifying faults can be exceptionally expensive. Operations and maintenance procedures for offshore wind farms are very finely tuned, and even minor deviations due to unexpected failures can result in very significant additional costs. So early warning of potential upcoming faults allows us to plan more carefully and execute maintenance activities in the most cost-efficient way. So, for example, when the wind isn't blowing and turbines wouldn't be generating electricity anyway.
The importance of further investigations in this field will be followed by the award of an EPSRC-funded research program grant, ROSIPS, which is worth around 6.3 million. It is being led by the University of Sheffield, but brings together a perfect team across the country with partners with complementary skills and expertise in machine learning, advanced data analysis, and new sensor systems. Specific offshore wind farm projects will be further developed and extend the knowledge and understanding of the research done in the Prosperity Partnership project, and this will drive new standards for safer, greener structures in the future.
The innovations from the research at Durham have resulted in an improved understanding of how to monitor the health of wind turbine drivetrain components. This has been done by online measurement of lubricating oil condition, the development of a novel prototype measurement system for monitoring the condition of turbine bearings using their acoustics, new control systems-based strategies for monitoring rotor system health, and new health condition monitoring techniques for generators and converters using signals embedded in their voltages and current flows.
So the work of the project to develop more efficient and effective ways of monitoring the health of wind turbine components is an exceptional example of research that can be directly applied by industry to improve commercial performance. Modern wind turbines are massive structures that ideally should last for the entire life of an offshore wind farm without needing replacement or without needing significant maintenance, ideally. Replacing a structure of this size in the harsh offshore environment is very costly and time-consuming, and that would result in significant amounts of lost electricity generation.
Our team of researchers in Hull have developed ways of design, manufacture and deploy key wind turbine components to improve their performance and increase their reliability. We've developed methods for using fibre optic sensors to monitor the casting of wind turbine blades to help improve quality, reduce waste and speed up the introduction of new designs. Improving the design of wind turbine blades by optimising structures so they achieve the required strength while minimising use of materials. In addition, researchers improved the understanding of the interaction between cables and the seabed, resulting in tools to assess the appropriate burial depth to ensure reliability and prevent damage. These advances will help ensure that manufacturers can have better control over the manufacturing process, improving yield and ensuring that the design and performance of these key elements of an offshore wind turbine are optimised, allowing them to operate more efficiently and for much longer periods of time. This in turn will help reduce the UK's reliance on non-renewable energy resources and ensure a greater percentage of the UK's energy mix comes from renewable sources.
Research partnerships like this have contributed directly to the phenomenal growth we've seen in offshore wind over the last 5 years by providing secure and clean energy at least cost to the consumer. The need to address the energy trilemma of sustainability, security and cost have never been greater given the ever-increasing urgency to address climate change and the current global, political and economic upheavals we see. Offshore wind will continue to play an ever greater role in addressing these challenges. The global rollout of offshore wind is set to accelerate exponentially over the coming decades, and the advances in technology provided by research programs such as a new partnership in offshore wind give the necessary technological foundations for Siemens Gamesa and the wind industry as a whole to achieve those goals.
This project has allowed Durham University to further strengthen our strategic partnership with Ørsted. The trust that has now been built up between the organisations has made it much easier to exchange data and expert knowledge. Working with our partners at Ørsted, Siemens Gamesa and at CC Jensen on projects that are directly linked to their research and development roadmaps from the outset is providing us with great opportunities to add value and create industrial impact from the research outputs.
Working with the university is a real draw to attracting top talents to work with Siemens Gamesa. It allows for engineers to develop their research skills as well as broadening and deepening their technical understanding. Also, the researchers we work with at the university have an opportunity to work directly on real-world technical issues and hopefully join Siemens Gamesa.
So the work of this project directly targets improvements in early warning of potential defects and helps us minimise the risk of needing to unexpectedly repair or replace components. Overall, improvements in health monitoring, operations and maintenance helps us to continually drive down the cost of offshore wind energy, and those are savings that are passed on to the consumer.
Our research addressed specific research challenges in design, manufacture and control of wind turbines, but working with colleagues in other research groups often inspires new ideas and approaches. The close collaboration with industry partners ensures the work remains focused on real industry challenges and aligns to wider needs of the sector. It also provides a great opportunity for wider collaboration and helps develop the future high-level skills needed to grow the sector.
When we started our collaboration with the University of Sheffield in 2009, offshore wind was seen very much as an emerging source of renewable energy and seen by many as being too expensive. But now we're able to say we've installed our first ever subsidy-free wind park, and we're proud to say the ideas developed through this partnership with the University of Sheffield has had a direct impact on the cost of energy. In May 2020, we signed a new 5-year agreement with the university to continue this collaboration, and that enables us to have a long-term view of the next stages of this research in this field and gives us the stability to engage in the longer-term developments that will reduce the cost of energy for offshore wind even further. The collaboration allows Siemens Gamesa to steer the university to apply their track record for innovation towards real-life issues facing the industry. It helps to focus research into areas that are more relevant and which will have immediate and positive impacts. This, in turn, ensures that our graduate and postgraduate researchers develop the right skills to enter industry and meet the current skills shortage.
As a result of advancements and innovations, including those from this project, we estimate that the cost of energy from offshore wind farms is now only 1/4 of what it was in 2009.